Alright, your starting system. Section 14, starting system. Description, maintenance, inspection, starting motor test, disassembly, cleaning, armature, servicing, field coil, checks, field coil, removal, assembly, pinion, clearance, service data, specification, equipment list. Alright, your starting system. Engine maintenance manual, electric motor division 645. The system consists of the dual starting motors with a heavy-duty Sprague drives associated with electrical wiring. Control of the dual starting motors are mounted above other and bolted bracketed assemblies, which is termed the attached rear end of the plate with of the engine. The flywheel pointer is bolted on the face of the bracket assembly. Typical dual electrical starting motor application. With the electrical engine starting sequence initiated with the actuation of the solenoid is energized solenoid plungers drawn with the solenoid at the bottom of the arm and the connecting linkage pushes the clutch to engage the pinion gear with the ring gear that is mounted on the engine flywheel. The pinion gear will remain engaged until the start switch is released. The pinion of the ring gear engagement is probably made with the solenoid plunger will have moved to the full extent with the travel near the end of the travel. The solenoid plunger in close contact with the solenoid housing initiates control circuits to energize the auxiliary starting contactor, which permits the starting motor to crank the engine. Do not operate starting motors more than 20 seconds at a time. Allow a 2 minutes cooling period before restarting the procedures. Overheating caused by excessive crapping will seriously damage the motor. Heavy-duty Sprague device, each of the motor, figure 4.2, provides the physical connection between the motor and the ring gear to prevent damage of the ring gear. Positive engagement features Sprague driver ensure the power does not apply with the ring gear until the pinion gear is meshed into the ring gear. The starting motor solenoid through the shift lever, the linkage pushes the pinion gear toward the ring gear with a tooth abutment occurs between the pinion gear and the ring gear with a spiral spline of the pinion gear sleeve. The push of the pinion gear causes the gear to rotate. The permanent meshing of the pinion gear ring of the gear before power is applied. The torque required to turn the engine over the carrier through the Sprague section located between the two concentric races inside drive of the upper and lower surface of each of the Sprague is covered with the offset of each from each other so that the Sprague rotates in one direction as radial heat increases. With the Sprague rotate for the opposite direction, radial heat increases the motor armature for the driven of the engine frictional forces between the contact and strip of the Sprague right gum races cause the Sprague to torque with the maximum radial height. With this wedges the Sprague between the two races to transmit so the torque of the motor armature for added to the engine. As the engine starts, the pinion gears forward, the engine rotates faster than the armature for the friction force of the now acting of the Sprague causes them to decrease their radial height and prevent the engine from driving the motor armature. Positive lubrication is provided into the bushings of the communicator end frame with the shifting lever housing of the nose housing with the oil saturated wick, which protects them through each bushing in the contact's armature shaft. Your maintenance. Under normal operation condition, no maintenance should be required other than the suggested in the applicable scheduled maintenance program. Inspection. Periodic intervals of the starting motor should be inspected to determine the condition of the response of the motor during engine start will indicate whether the inspection of the maintenance is required. The addition with the operational check with the following conditions should be noted. Check the starter solenoid mounting bolts of the screw of the terminals in good condition, and if the solenoid switch is defective, it should be replaced as an assembly. Remove the brush inspection plugs. Check the communicator brushes, the internal wiring. Check the evidence solder thrown from the communicator. If the communicator signs of the surface roughness of the high milk, thrown solder with the necessary to remove it from the motor of the maintenance glazing on the communicator. Tater can be removed by holding a strip of 00 to 00 sandpaper against the communicator with a piece of wood while operating a motor for a few seconds. Inspect the brushes to make sure that they are not binding. So they are positioned against the communicator with the end tough tension to provide good contact. Check with the brush sleeve of the screw and the brush holders for condition and security. If the brushes are worn to one half of the original new length, then they should be replaced. Starting motor test. If some of the locomotive application starting motors at 32 volt with connected in series with the other locomotive application starting motors at 64 volt are connected in parallel, the test procedure should differ with the application 32 of 64 will be shown where the procedure is the same or both types of the application will same for the both types. The application will not be shown. To obtain the full performance data for the starting motor, determine the cause of the abnormal operation starting motor. Be subject to the following tests. The test should be performed in the starting motor. Remove the engine failure. The starting motor to provide perform according publishing specification will require disassembling the motor. Further checks and adjustment. Well, with the starting motor, with the remove of the engine, the armature should be checked with the freedom of operation, turning drive with tight and dirty, with the worn bearings, armature shaft, loose pole shaft, shoe screw will cause the armature to drag. If the armature does not turn freely, though, through the sum of the brush drag is normal, the motor should be disassembled without further testing. If, however, the armature does operate freely, the motor should be tested electrically before disassembly. Alright, your no-load test. Connect the starting motor in series with a DC power source with an ammeter capable of reading several hundred amperes of various variable and variable resistance. And the shown figure 14.3. Also connect the voltmeter with the motor terminal to the motor frame. An RPM indicator is necessary to measure the armature speed. Proper voltage can be obtained with the varying resistance. The 32-volt motor run the motor for motor free at 30 volts with a maximum period of 30 seconds. Speed should be 5,300 to 7,700 RPMs. Current should be 770 to 105 amperes. Figure 14.3 shows the motor test circuit. It shows the battery variable resistor, motor field terminal, ammeter, voltmeter, motor, battery switch, solenoid. The 64-volt run the motor for 30 volts with a maximum period of 30 seconds. Speed of 5,300 to 7,700 RPMs. Current should range from 60 to 95 amps. Test indication, rated current draw with no lead speed indicate the normal condition. Starting motor, low speed and high current draw indicate the too much friction, tidy, dirty, worn bearings, bearing armature shaft, loose pole, shoes allowing armature to drag shorted armature. This could be further checked with the growler after disassembly. Ground armature with the fields checked further after disassembly. Failure to operate with a high current draw indicate the direct ground in the terminal of the fields. Frozen bearings should have been determined by determining the armature by hand. Failure to operate, no current draws indicates. Open field circuit that can be checked after the disassembly inspection of the internal condition tracing circuit with a test lamp. Open armature coils. Inspect the communicator for the badly burned bars. After disassembly, broken brush springs with warm brushes, high insulation in between the communicator bars. Other causes of the wood prevent good contact between the brushes and the communicator. Low no load speed, low current draw indicate high internal wind resistance due to pro or connection defective leads. Dirty communicator cause listed unspecified. Step 4, 6 high free speed, high current draw indicate with the short field. The short fields are suspected to replace the field coil. Assembly check with improve this performance. Or your disassembly, solenoid assembly removal. Disconnect the motor terminal lead from the solenoid terminal figure 14.4. Remove the plug with the level housing, expose nut with a secure plunger, spring assembly to shift lever. Remove the 4 screws holding the solenoid assembly to the field frame, and remove the solenoid. Remove the nut from the plunger, holding large end of the plunger, which was separated from the solenoid housing. Drive clutch removal to mark the position of the nose housing in relation to the lever housing. Remove the 6 screws. Screw nose housing to the lever housing. Move nose housing, being careful not to damage the shaft bushing. Remove the clutch assembly by pulling the armature shaft. Your armature removal to mark the relative position, level position of the CE frame and the field frame, and remove the 7 screws securing the level housing frame. Carefully remove the lever housing armature of the field frame, the condition of the oil seal bushing and the O-ring at the frame and contact area. The CE housing, the 3 bushes, remove the 3 bushing plugs, and then remove the brush, the lead screw. With this will also disconnect the field lead with the brush holders. Remove the 6 screws securing the CE frame to the field frame, and the removing of the CE frame and the no condition of the bushing of the O-ring in the front frame contact area. Cleaning. Overrunning clutch armature fields should not be cleaned in any degreased tank or with grease dissolvent, since they would dissolve the lubricant with the clutch mechanism. Damaged insulation armature field coils. All parts except for the clutch should be cleaned with the aluminum spiritual brush. Clutch should be wiped with a clean cloth. With the communicator dirtier, there may be claim number 00 sandpaper. Never use emery cloth with a clean communicator. Alright, it shows your typical electrical starting motor cross section. Shows your CE frame, O-ring, gaskets, brush inspection, field frame, gasket, solenoid switch, plunger, linkage seal, link inspector, linkage shield, oil reserve shaft, seat, oil ring, oil reservoir, lever housing, spring snap, spread clutch, oil reserve, nose housing, ship lifter. Alright, if the armature of the communicator is worn and dirty out around the high insulation, the armature should be put in a lathe with the communicator be determined. The insulation should be undercut with 1/32 of an inch and by 1/32 of an inch deep. The slots cleaned out of the remove the trace of the dirt and copper dust. This final step of the procedure for the communicator should be sanded lightly with a number 00 sandpaper to remove any of the burrs left to resolve the undercutting. The armature should be checked with the open short circuits of the ground. It's followed with the opens usually caused with the excessive long crank periods, most likely placing an open curve with the communicator riser bar, inspecting the points where the conductors are joined with the communicator bars, loose connections. The poor connections cause the arcing, burning over the communicator bar with the starting motor is fused. The bars are not too badly burned. Repair can often be affected by welding the leads of the riser bar, turning down the communicator on the lathe, remove the burned material. The insulation should then be undercut. Short circuits of the armature are located. The use of the growler with the armature resolve the growler with a seal strip such if the hacksaw blade held above the blade will vibrate above the armature core with the short circuit located at the end, so between the bar with the sometimes reduce the brush dust copper between the bars. These shorts can be eliminated with cleaning out the slots. Our grounds of the armature can be detected by the use of the 110-volt light test lamp with the test point light lamps. One test point placed with the communicator with the other point on the corridor of the shaft. The armature is ground with the grounds occur with the result of the insulation failure with the which is often brought with the overheating. The starting period motor produced with excessive long cranking period with the accumulation of the brush dust between the communicator bars and the steel communicator ring. If any of the conditions are not corrected, the armature must be replaced. Or your field coil check. The field coil can be checked with the grounds openings using a test line figure 14.5 of the applicable wiring diagram. Grounds connecting one lead to a 110-volt test lamp with the field frame and the other lead to the field connector. If the lamp lights, at least one field coil is grounded and must be repaired and replaced. If open contact connect test lamp leads to the end fields of the coil lamp and does not light, the field coils are open. Your field coil removable. Field coils can be removed. The field frame, the assembly of the pole shoe, screwdriver, the pole shoe, with the spreader, with the use of the prevent the distortion of the field frame. Carefully installation on field coils is necessary to prevent shorting and the grounding of the field coil. Pole shoes tightened into place. Where the pole shoe is long lip of the one side of the short lip at the other. The long lip should be assembled with the direction of the armature rotation becomes of the trailing, not leading edge of the pole shoe. Assembly to assemble the motor procedures as follows: lubricate armature bearings, communicator end frame, shift lever housing, nose housing from the SA number 10A 10 oil figure 14.4. Install armature into the frame lead assembly. Assemble communicator end frame of the frame by pulling the armature out of the field frame just far enough to permit the brushes to place over the communicator. Push the communicator end frame the armature until the end frame mates with the field frame. Be sure that the O-rings are in place. Install the tightening 6 screws and hold the end frame to the field frame. So this shows your terminal locations on the communicator end frame. 32-volt terminal location on the communicator end frame. 64-volt. And then it shows Alright, 4. Connect the field brush leads. Install the 3 bushing brush ends back plate to make the lever housing field frame being with the sure with the locking marks are aligned with the O-rings are in place. Install tighten 7 screws and hold the lever housing of the field frame. Then check the thin coating of the SAE number 10 oil to armature shift the spline with the matching clutch and the assembly splines assigned. Also clutch assembly, spiral splines, and mating position of the gear splines. 7. Apply grease to the 2 bushing clutch assembly bore. Install the clutch assembly, the nose housing, leveler housing. Be sure the 2 housings are aligned that they will be before installing. Installing the set screws tighten to 13 foot-pounds of torque. Install solenoid assembly on the lever housing. Connect plunger shifter to lever the screw nut on the plunger shaft. Install 4 screws in which hold the solenoid assembly field frame and connect with the motor field with the terminal lead and the solenoid terminal SW with the inspection plug is in the lever housing can be left out until the pinion's clearance is adjusted. Add SAE number 10 oil to each of the wick lubricator. Remove the plugs outside of the motor from the 3 lubricating points. Pinion clearance. Check the pinion clearance after assembly of the motor. Make sure the clearance is within limit to figure 14.6. The pinion must be held in the crank position electrically utilizing the solenoid holding coil to achieve the proper relationship with the pinion of the solenoid shaft with the contact disc. Figure 4.16, checking pinion clearance shows the shaft nut press on clutch take up much more. Alright, to check the pinion, follow the steps listed below with the disconnect the lead connection with the solenoid with the SW terminal with the motor field terminal with the motor field terminal. Connect the battery at the same voltage with the solenoid BA I terminal with the unframed flat terminal with the solenoid with the energized solenoid holding in coil. Monetary flash to leave the solenoid SW terminal solenoid unnamed flat terminal. The pinion will now shift to the crank position, remain until the battery is disconnected. Push the pinion back toward the communicator end to eliminate the slack movement. Measure the distance between the pinion and the pinion stops. This should be between 23/64 plus or minus 1/32 of an inch. To adjust the pinion clearance, the plug is removed the solenoid linkage portion of the lever housing solenoid shaft. The nut is turned until proper position. Proper pinion adjustment is achieved. And then it goes over the service data of the starting system and your equipment list. And this was Section 14 starting system of the electric engine maintenance manual for the electric motor GM. Section 1464 645 motor.